All right, let's jump right into this explainer and uncover what is arguably the central mystery in tech today. How are these massive tech giants actually trying to build artificial general intelligence? Look, if you just listen to their PR teams, everyone is vaguely building the future, right? But if you look past what they say and carefully examine what they're actually doing with their billions of dollars, a really fascinating picture emerges. Today, we're going to reverse engineer the dominant strategies shaping the future of AI. Our goal here is to help you separate the marketing hype from the actual, literal blueprints of tomorrow. To build a clear mental model of this landscape, we're covering 5 key areas. First, the intelligence race. Second, Bet 1, pure scale. Third, Bet 2, architectural shifts. Fourth, Bet 3, agentic systems. And finally, we'll reveal a pretty massive plot twist in Step 5, the great convergence.
Okay, part 1, the intelligence race, chasing artificial general intelligence.
Right now, the entire frontier of AI is sprinting toward AGI. But here's the catch. These companies don't exactly publish open roadmaps titled, "Here is our exact philosophical bet." There's no neat taxonomy. Instead, we kind of have to play detective. By following the money, analyzing product releases, infrastructure investments, and research agendas, we can actually infer 3 distinct dominant bets being placed across the industry.
Which brings us to part 2, Bet 1, pure scale, or what we can call the brute force method.
So this first bet, it's basically like trying to build a biological brain by simply cramming in as many raw neurons as humanly possible. Think of it as the ultimate brute force method. The core belief here is a very straightforward equation. Capability equals model size plus data plus mountains of compute. Organizations following this philosophy optimize strictly for the largest training runs and winning those frontier benchmarks. They are acting on a very clear signal, the idea that bigger, more capable base models will simply unlock everything else downstream.
Now, what's really interesting is how different companies apply this exact same brute force philosophy. OpenAI still drives these massive compute contracts, clearly believing that a general GPT-class model is the universal interface. But look at Meta. Their open weights ecosystem signals a belief that raw scale, combined with open distribution, is the ultimate driver of intelligence. And xAI? Well, they have this massive compute-first culture. They're spinning up giant GPU clusters, signaling a very direct, undeniable equation. More compute literally equals more intelligence. But brute force isn't perfect. Now, this view is incredibly strong because, frankly, scaling laws still hold true in practice. Every major leap in coding or multimodal capabilities correlates perfectly with scale increases, but it has noticeable blind spots. It really struggles to explain how we achieve persistent memory or long-horizon autonomy, meaning the ability for an AI to execute a complex plan over several days or weeks. Simply adding more neurons doesn't automatically teach the brain how to plan for the next 5 years, right?
All right, part 3. Bet 2. Architectural shifts, or the new blueprint method. This path argues that raw brain size just isn't enough. We actually need entirely new structural wiring. We call this architectural discontinuity. The core belief here is that current transformer-based systems, which is the architecture behind almost every major AI today, are missing fundamental cognitive primitives. Basically, they lack common sense. So instead of just scaling up text prediction, these organizations are optimizing for causal world modeling, literally teaching AI how cause and effect work in physical reality, and building memory systems that go way beyond standard context windows. The clearest signals for this bet come from places like Google DeepMind and Safe Superintelligence Inc., or SSI. DeepMind is heavily focused on world models and simulation-based learning. They strongly believe intelligence requires a structured internal model of the world, not just a knack for guessing the next word. SSI takes an even stronger stance, explicitly avoiding product pressure to focus on a brand new paradigm beyond transformers. And Anthropic is making a really cool hybrid bet here, investing heavily in the structural glue for cognition, signaling that the transformer is necessary for sure, but absolutely not sufficient on its own. Now, this architectural approach brilliantly explains some of AI's most frustrating, persistent failure modes, things like hallucinating in novel situations or having brittle planning capabilities. A structured internal world model theoretically solves all of that. But the glaring weakness. Historically, these new architectures have rarely beaten scaled-up transformers in a direct head-to-head fight. Often, proposed alternatives eventually just kind of collapse into being a transformer variant anyway, just with some extra scaffolding attached. So, if raw scale isn't perfect and new architectures are struggling to win outright, where exactly do we go? That brings us to part 4, Bet 3. Agentic systems, basically prioritizing the system over the model itself. So what if the secret isn't a bigger brain or a differently wired brain, but what the brain can actually do? This is currently the fastest growing practical paradigm in the entire industry. It's all about giving the brain hands and tools to interact with its environment. The crucial point here is that a model alone just isn't enough. AGI will be an emergent property of closed-loop systems. We're talking models, plus tools, plus memory, plus orchestration, plus constant feedback. True intelligence is how that model operates within a broader compositional system layer. Let's look at the players making this bet. Microsoft is probably the most explicit here. Their Copilot is a system, and they're heavily investing in multi-model routing and enterprise tool integration. Anthropic is also arguably a leader in agent execution with Claude Code, treating intelligence as reliable action within a specific environment, like a code base. And Amazon AWS, they're treating this purely as infrastructure, signaling that agents are essentially just cloud workloads. The model acts as the brain, absolutely, but the actual product is a system of actions. The beauty of this system-level bet is that it aligns perfectly with real-world economics and usability. It matches how AI is actually deployed out there for multi-step tasks, prioritizing the cost per task over the cost per token. However, its major weakness is a total dependency on the base model. If the underlying models fail at basic reasoning, the whole system collapses into what we call workflow theater. Lots of flashy moving parts, but absolutely no true intelligence gains. Okay, now for the ultimate plot twist. Part 5. The Great Convergence, the Stack Reality.
So the reality here is that no major player is purely in one single camp anymore. Actually, scratch that. It's more like these competing philosophies are actively merging into a single ecosystem. When we stack these concepts together, kind of like building a house, we see the stack reality. We have the scaling layer at the foundation, the architectural research layer refining the middle, and the agentic system layer sitting right on top. It's a unified ecosystem where different companies are tackling distinct layers of the exact same puzzle. And honestly, this brilliantly illustrates the actual commercial strategic truth of the AI race. Think about it. First, scaling defines the absolute capability ceiling. Without strong models at the base, everything else just collapses. Second, architecture defines the efficiency ceiling, determining reasoning stability and memory depth. And third, agent systems define usability and economic product value. Without agents at the top, there is literally no enterprise adoption. This stack is exactly how the future of software is being built.
This entire shift is perfectly captured by this idea. The industry split is not ideological anymore. It's a division of labor across the same stack. The seemingly chaotic, cutthroat race for AGI is actually a highly structured division of labor. You have OpenAI, Meta, and xAI pushing the absolute ceiling with scale. You have DeepMind and SSI exploring structural alternatives to make things stable. And then you have Microsoft, Anthropic, and the enterprise ecosystem turning those models into operational systems that actually do real work. So as we watch these distinct layers converge into a single, incredibly powerful stack, the real question that remains, and the place where the sharpest disagreements in the industry still exist, is this. Which of these layers will actually dictate the timeline for when true AGI finally arrives? Will a massive new GPU cluster cross the finish line first, or will a new architectural breakthrough suddenly unlock the future? Keep your eyes on the stack, because that is exactly where the answer is being built right now.